I'm an idiot. I'm such an idiot. For number one, I input 4 instead of 5.
It'll take a second. Somebody asked me about the curves. Test A, I think is the one. It has average was 17 out of 40. It's got 4 points added on to the raw score. In other words, if you made 20, it would be 24 out of 40. Got it? You would add 4 points to the raw score. Test B, there was no curve for test B. The average on that is just about 30 out of 40. All right? Everybody here? Yeah.
So the average on one test was 30
Quite a
out
bit
of 40,
different, right.
and one average was
Yeah, and it was
21.
due to not knowing how to do complex numbers on your on the count. That's the reason there's a curve on that one.
Okay.
Now, I'm going to go through it. Hear me now. If you blew it, there's still time. But it gets harder. And if you don't know this material, you're just kidding yourself. You cannot cram for this class. You'll be destroyed. And I'm trying to warn you. I want to be serious about this. You know, I hate to see it. Seniors graduating seniors fail us 2-3 times. I've had a kid do this, and it's like, what's wrong with you? Hear me. Spend your time on this when the assignments are given. Don't wait. You'll get killed. Can't say any clearer. We're going to go, this is test A. I'll do test A1, or first problem's test A, and first problem's test B. Real quick. All right. Class, pay attention to this if you've got this test. This is straightforward. I want you to hear me now. All right, when I look at this, it's a simple resistance problem. These are gimmies. I have 8 and 4, that's 12K. Got it, class? That is in parallel with 4K. 12 in parallel with 4 is 3. 3, 3, 3. There are 3 3s in parallel. That makes it 1. You all see that, class? 1 plus 5 is 6. 6 in parallel with 6 is simply 3K. 3K is the answer for that one. Everybody hear me on that? All right, it is a straightforward problem. There are no tricks to this. This is a problem right out of the book. Got it, everyone? Now, I'm going to go through the first part on the other test and come back to this one. This was a little harder problem. It's more involved. Same principle. Here, they're all in series. That's 24 ohms. I've got 6 and 8 and 10. It's 24. It is in parallel with 5. You all see that, everyone? That means I take 5 times 24 over 5 plus 24, get a single resistance that replaces that stuff. Then I've got that resistance in parallel with 4 and 12, or 16. So I have 20.4 in parallel with 5 plus 16, right? This whole leg is in parallel with 3K, or the 3 ohms right here. Do you all see this? I take that times 3, that over 3 plus whatever that is. Finally, I add 16 to that because there's 10 and 2 in series with that. The answer is 18.61 ohms. No matter how you do it, you get that answer. Everybody follow me on this, class? They were straightforward. They're just checking boxes. You know how to add resistors in parallel and series. That's the first one. Now you know the next part is how to add complex numbers, series and parallel. And this is just using your calculators. Here for this one, I have two impedances in parallel. I have 60 plus J20, and I have 40 minus J100. You all follow me? You can label this impedance as simply Z1, and this impedance as Z2. Then the total impedance, Z total, is just going to be 50 plus J, 30, plus Z1, Z2 over Z1 plus Z2. Your calculators can do this. You do this, put the numbers in your calculator, out pops 104 at an angle of 94.1 degrees. If you have specific questions on how I got that answer, I'll lay it out in great detail. It's a very simple thing. You're multiplying 2 complex numbers and adding 2 complex numbers to get the net value or the parallel combination. Then you're adding 50 plus J30 in series. I wanted it in polar. I don't believe they took off points if it wasn't, but it should be taken off points, and next time you will. If it's asked for polar, I can only be magnitude and angle. Does everybody hear me, class? Now, next, after that, I'm going to go to the second problem. Specifically mesh analysis. This is straightforward as they get. Actually, this is a homework problem. The only thing different is instead of having a circle there, I put a battery. That's it. Literally. So watch. For this one, I'm going to come around this loop. Remember, this is mesh, and I've assigned the currents, I1, I2. So I know the sum of the voltage drops around any closed loop is 0. You all hear me? All right, when I go around this closed loop, I got an increase of 28. Then I got minus, and it's going to be 4 times I1. Do you all see that? Then minus 2 times the net current flowing down, which is I1 minus I2 equals 0. Do you all see this, class? Show of hands how many see this right here and understand it. You have to understand this in order to proceed. Now, That's the first loop. Forget about breaking it down here for now. Go to the second loop. Second loop, I start here. This is how I do it. Some people start here. Fine. The same equation comes out. I start here. Now I get minus 2 times the net current flowing up, which is I2 minus I1. You all see this, class? Next, I come here. I have minus 1 times I2. Only I2 flows in the second loop. You all see that? Then when I come here, then I get minus 7 equals 0. Understand? Those two equations are the essence. They're as great as we're looking for. If you've got those two, you got 50% basically of the problem. 5. Now you assemble them in a matrix. You simply collect terms and assemble them. The matrix should look something like this. Minus 6, 2, 2 minus 3, I1, I2, minus 28, 7. Solve, you get 5 for I1, 1 for I2, and V naught right here, which is this value, V naught, is simply 2 times I2 minus I1. Do you all see that?
Can you show your matrix, please?
It's right here. So, it's just a straight square matrix. There's nothing tricky about this. And then you turn the crank and you get these numbers. All right? Was meant to be as simple as possible. It's right out of a homework problem. Literally a homework problem. I changed, I think, the value of the voltage and put in a battery. That's it. For this one, same deal. Mesh on this one. Now here, I start, I'm going around this loop. I get an increase of 20, then a decrease of 10 I1, then a decrease of 50 times I1 minus I2, and a decrease of 10 equals 0. That's the first equation they're looking for right there. Y'all see it? There should be no ambiguity about this. It's the way I did in class several times. Probably 5 or 6 times we've gone through this very simple procedure. Next loop starts here, right? Right? Increase of 10, minus 50 I2 minus I1, minus 100 I2 equals 0. You all see that? Those two equations, the box matrix isn't here, but these two equations are the equations that are solved. They're just the coefficients. In the first matrix, it will be minus 60, 50, and 50 minus 150. Then I1, I2 equals minus 10, minus 10. You all see that, class? There are two equations, two unknowns. You stick it in your calculator, turn the crank, and out comes the values. It should be I1 is equal to 0.308, I2 is 0.169 or 11/65, and V naught in there is going to be 50 times I1 minus I2, and it's 6.923 volts. Everybody see this? It's meant to be straightforward. It's meant to be as easy as it seems, all right? There's nothing tricky about this. Next problem here. Now this is complex numbers. Again, you have to know how to use your calculators. Without that, it's an assumed thing. If you don't know how to use your calculators, you will fail this course miserably, especially when you get into power. I can't be more clear. I try to make sure you hear me. Some people still don't. You have to know how to use your calculators with complex numbers efficiently. All right. For this one, I said specifically nodal. It doesn't mean you can't do Thevenin, you can't do mesh, you can't do superposition. It said nodal. All right. I put the currents, I put the voltage V here. Now these currents you can assign any way you want, because the final form of the equation will be the same. Here I took my I1 going that way, I took I2 there, and I3 here. You only need one equation for this problem. It's not like the other test gets the harder problem in a sense, because they have two equations. For this one, I have I1 equal to 2. I1's going that way. What's coming out? Anything into a node comes out of a node. Now some people have got to say this. They've been looking online, talking to their friends. They say, well, the way it's really done is the sum of all the currents entering a node is 0. So they take all currents entering a node. So they're always going to take currents entering a node. Now just watch how this breaks down here. I1 would be fine, right? But instead of having 2 amps there, they would put minus 2 as entering the node compared to that current. Then here, instead of having I2, it would be minus I2, and then minus I3. Do y'all follow me there? So they'll do that and they'll set everything equal to 0. If you know what you're doing, fine. But I prefer, because I know engineers well enough to know, if you get a certain method done in your head, you do it over and over again the same way, you're less likely to make a mistake. Anything flowing in is flowing out, is the way I do it. All right? That's the way I do it. So what flows in? I1. What flows out? 2, I2, and I3. That's me. All right. What is I1? Right here, it's the voltage 12 minus the unknown voltage V over 2 minus J1. You all follow me in that? It's voltage difference, right, in the direction of current flow divided by impedance. Everybody got that? Next, There's 2 amps coming down, that doesn't change. How much current is flowing through there where I2 is? Well, it's the voltage V over 2 plus J2, correct class? Right, because it's 2 plus J2. How much is the current I3? Well, it's V minus 4 over 1, right? So this equation. Now, you've got to solve it. That's 50% if you got it, but you have to solve it. And after you solve it, you can do it a lot of ways. I'll show you the way I do it. I just go ahead and I factor, I get the values of the constants on this side. So I have 2 minus 4 is going to be minus 2, shifted to this side is plus 2. I leave the 12 minus J1 on this side. Y'all see this? So I leave this constant, 12 minus J1, and shift the 2 over here. Then I take the coefficients of V, so I have to take the minus V over 2 minus J to this side, makes it plus V, 2 minus J. Factor out the V, I got 1 over 2 minus J plus 1 over 2 plus J plus 1. You can do complex numbers there, just get a single number there if you want. Doesn't matter how you do it. Finally, when you go ahead and solve for V, you have 2 plus 12 over 2 minus J over this, which is this coefficient, and it equals this. Now you can do it so many different ways. People have all sorts of intermediate steps here, it's fine, but you have to know how to get the final answer. Magnitude and angle. There's no partial credit when it comes to that. You've got to get the right equation and the right answer for the full credit. And then finally, that's V. Now that's that voltage here, but I wanted V naught, and V naught is going to be the voltage there times 2 over 2 plus J2. Do y'all see this, class?
Can you lower
That's
it?
it.
Can you lower it?
I'm sorry, what?
I was asking
I'm sorry.
you to lower it.
I'm bad. Once you had V, you had to do voltage division. Now, I'll admit one thing. If you didn't know how to use your calculators, this problem would strike you, right? It would hurt you. If you know how to use your calculators, there's one equation, one unknown. It's a simple problem, but you have to know how to use your calculators. All right, next one over here. This is a more complicated problem in the sense that you had to write matrix equations. Nodal analysis. This has 2 nodes. I put down a V1 and V2. So I label the currents I1 flowing through the 2 ohms, then I label the current I0 flowing through the 2 ohms, and I3 flowing through the 1 ohm, and then I3 flowing through the minus J1 ohm capacitor. Y'all hear me? Now here, it's always what goes in comes out is the way I do it. So for the first equation, what goes in is I1, what comes out is 2 plus I0 plus I2. And again, this is my standard of doing business, top to left. I should say top to bottom, left to right, and I start usually with I1 if I have a choice. I0 is already there. Understand, class? That's it. Now you put in what the values are in terms of the actual impedances. Well, I1 is 12 minus V1 over 2, right? Over here, when I look at I0 is V1 over 2. I2 is going to be V1 minus V2 over 1. Do you all see that, class? Are you clear on that, everybody? All right, that's the first equation. This is when it's modified to get rid of the half. You're going to multiply by 2. You end up with this basic equation here when it's all said and done. Now the second equation right here for V2, or the second node, what flows in is I2 right here, but 4 flows in as well, is equal to I3. Now you go ahead and put in the values. So when I have that, I rearranged it and I took I3 minus I2 equal 4. So I look at this and I say that I3 here is going to be V2 over minus J1. I2 is going to be V1 minus V2 over 1, right here, equal to 4, that's that. And it's just some manipulation, you get this. Now we have 2 matrices. The coefficient matrix of this would be 4 minus 2 minus 1 and 1 plus J equal to 12, or it's really V1, V2 equal to 12 and 4, right? And then you're going to solve and you'll get these values. V1 is 5.215 at minus 32.47 degrees. V2 is 6.261 at minus 63.435 degrees. And I0 is simply going to be equal to V1 over 2, and that's 2.608 at minus 32.47 degrees. These are the hardest problems. Yes, sir?
Can you move the paper up?
Yeah, I'm sorry. I'm going to post these things. Yeah, I'm sorry if it doesn't. Yes, sir?
What are the values of let's see, V1, V2, and I not back, so other polar values like.
These are answers probably, this is from the graders. They were writing those down as common. I don't really know what they mean, to be honest with you. Because I gave them my solutions and they just gave them back to me.
Okay.
Those numbers aren't right.
They are.
The right ones are there, they should be. Yes, sir.
Where did the two come in next to the V1 on V2?
All right, hold on. You're gonna have to have this
No, the 2 times, yep.
here. Well, they started with this basic equation.
Oh.
I1 was 12 minus V1 over 2, right?
Yeah.
And there's a factor of 2 that they multiply 2 through, so you gotta have a 2 here.
So you multiply the 2 in a second.
Yeah, you have to. And I want to say one other thing. All these equations can be multiplied or divided by anything, and they still are true. You hear me on that? So if you have a correct answer, even though all your coefficients are twice as much, it's still okay. All right, that's the reason why. Everybody understand this class? Because a lot of people didn't understand that basic thought process and answered a lot of questions. All right. Finally, the last problem. There are 2 different problems. This is the transient current problem through an inductor. All right, listen up, folks. You're going to see this kind of stuff again, and I'm trying to give you some advice here. First, notice the switch closes at t equals 0. You have to know how the switch is operating. It's going to close at t equals 0, not open. So, when you go and notice that, the first thing I say to do is find a current at t less than 0 through the inductor, correct? If the switch is not closed, there is no voltage across the inductor. Nothing can happen, it's 0. Does everybody hear me? There is no possible way current can flow if that switch isn't closed. Does everybody see that? Show of hands, everybody. If you see this, because if you don't, you need to talk to me because you really got a problem. Now, after the switch closes, we have to find the current through the inductor as t goes to infinity. This is an important concept. At infinity, what does the inductor look like? Short circuit, right? A wire, right? Because there's nothing time varying. So you replace that inductor with a short circuit. You'll notice that all the current goes through the inductor, not the 4 ohm. Does everybody see that? Everybody see that? Now how much current? It's just 12 over 8. You all see that? Or what? 3/2 of an amp. Everybody see that, class? That flows. The next thing you need to do is find out what the Thevenin equivalent resistance is after the switch closes. After it closes, do you see you have 4 in parallel with 8? Does everybody see that? Because the source voltage looks like a short, doesn't it? How many see this now? 4 in parallel with 8, not in series, in parallel, right? That means tau is equal to R Thevenin times C, correct? And then you can assemble your solution. K1, I'm talking through it, because this one troubled me. I thought everybody would nail this thing. And about half of you did, at least. You got it perfect on these things. Let me finish my thought here. But a lot of people, for whatever reason, messed up the switch. And I don't know, there were a lot of switching problems I gave you. This is literally the switch that was on load. All right, so the final form is going to be K1 e to the minus t over tau plus K2. Now K2 is going to be the value of the current as t goes to infinity through the inductor, right? That current has to be equal to the current through at t equal infinity, or 3/2. The next value you're going to get is what? I know K1 e to the minus t over tau plus 3/2 is equal to the current for all time. To get K1, you check the current at t equals 0, which was 0. Understand, class? So you put 0 equal to K1 plus K2, or K1 is minus K2. Follow me on this? And you know K2 is 3/2. The final form is this. It's 3/2 times 1 minus e to the, or 3/2 times 1 minus e to the minus t over 3/4. Because the time constant is R Thevenin times C. It wasn't meant to be hard. It was literally drafted right from a problem I gave you. That one. Final one, over here. This one is a little tougher, in my opinion. For this one, because there's 2 values you got to get. I look at this, and for t less than 0 is the voltage. Now it's voltage, not current, right? Y'all are going to see this again. When I'm talking about a capacitor, what does it look like for t less than 0, for all time less than 0? Class? Open circuit, right? It's just there's nothing there. It's an open circuit, an infinite resistance. So with that in mind, no current can flow through it. Got it? If no current can flow through the capacitor, the voltage here to here, now listen to me carefully on this one. This voltage for t less than 0 is the same as this voltage, right? Because that 6K does not have any current through it for t less than 0. How many understand this point? Right? If the capacitor looks like an open circuit for t less than 0, and I'm at t less than 0, no current can flow through the capacitor. And therefore, no current can flow through that 6K. Do you all hear me on this one? You don't do voltage division here. Now that means the voltage across the whatever that K is, can't read it. The 8K is the same thing as the voltage across that capacitor. And what is that voltage? Well, it's 12 times 8 over the sum of 10 and 18, or 18, and it's really just 16/3 of a volt. How many see this right here? For t less than 0. Now, for t greater than 0, now when the switch closes, and it does this, basically, now when it's closed, I'm looking at the voltage as t goes to infinity, right? What does a capacitor look like as t goes to infinity, class? Open circuit again, right? We're at t equal infinity. All right, if it's an open circuit, how much current can flow through it? None, right? How much current flows through that 6K, class? None, no current, right? At t equal infinity. Do you follow me what I'm doing here? I'm trying to show you. If you made a mistake, catch it right now. Never make it again. Now, that means the voltage across that 8K ohm is the voltage across the capacitor as t goes to infinity. Show of hands, how many see this? Forget your score for now. Make sure you see what I'm saying. Are you with me? If you don't see it now, you're really in trouble. All right. Now, if that's the case, I have the voltage, which it happens to be the voltage across the 8K, which is just 6 times 8 over 18, right? Which is exactly half the voltage it was for t less than 0. Isn't it, class? Now you assemble the equation. The equation is always K1 e to the minus t over tau plus K2. K2 is the voltage on the capacitor as t goes to infinity. Got it? We've got that. How do we get K1? We go to t equals 0, right? And we have the voltage for t equals 0 from before. It's 16/3, equal to K1 times e to the 0, or 1, plus K2, which is 8/3. It means K1 is 8/3. Do you all see that, class? Show of hands, how many do? And that was the method. That's the whole test in a nutshell. It was based on 4 homework problems. All of those were meant to be something that were, if you knew what you were doing, you would have no problem. If you didn't know, you would be in a world of hurt. And it proved to be true, especially with complex numbers. Now, the last thing I'm going to say to you today, and I want you to hear me. If you fouled up this test sideways, for whatever reason, it doesn't matter. You're calculating, you just didn't think it was a big deal. Then whatever the problem is that you see, that you have, if it is something about not knowing how to use the functional formula calculator, spend a lot of time and learn. It's whatever it takes, learn. I'm going to give you a lot more problems. I'm going to give you some more problems with this chapter, but we're moving into chapter 5. Now, the reason I'm being a little more emphatic about some of the things I'm saying here and try to really underscore it is because if you have trouble with this material, you'll be lost forever when it comes to power and the other. What we're going to is assuming this is second nature. This is the simple stuff. Where we're going, it gets much, much tougher. So please make sure you do what I say. Find out where the problem was. If it's concepts, get yourself straight with concepts. If it's your calculator, you don't know how to use it, figure out how to use it. These problems, each one of these problems is made for at most 10 minutes. I want you to know this. This was actually, right, at most a 40-minute test. Frankly, I think if I would have given you another hour, some people would still be trying to play with your calculators and figure out how to do stuff. So please learn how to use your calculators. The concepts here are not tough. They're not very difficult. They're fairly straightforward. You're not solving second-order differential equations. You're not doing Laplace transforms. You're not doing any of that stuff. It's very basic engineering. But your calculators will kill you if you don't know how to use them. And that, which, in my opinion, that was 90% of the problem is class for the mistakes. You didn't know how to use your calculator. So learn. You can go. If you got questions, you can